Hello, everyone. Welcome to today's IEEE IoT Technical Community webinar. I'm going to hand it over to our host, Wenchin, to bring you to today's session. Thanks, everyone, for joining. Over to you.
Thank you, Craig. Welcome everyone, and welcome to today's IEEE IoT Technical Community Distinguished IoT webinars. And our today's topic is UAV challenges and applications. So before our speaker, Professor Carlos Calafate, to do his presentation, and let's see, I would like to do some introduction to the IEEE IoT TC. Um, so, um, what are we doing here? So the mission of the IEEE IoT technical community is trying to set up a place that people can gather. The global technical community can working on the IoT can gather, and also we also want to provide a platform for people to learn, to share, and to collaborate. So if you'd like to join our community, and please have a look. There's a link at the bottom of your screen. And so if you click the link, and you will be able to find out where to register to become a member of us. And these are our generous sponsors to sponsor our activities. So including this webinar. And so we're very lucky to have them to support. And again, if you want to join us at the bottom of your screen, there's a link, and you can find out where to register to become a member of us. So the upcoming IEEE IoT TC's events, so our flagship conference, WF IoT, so next year will be in Abu Dhabi, UAE, and the website and call for paper will come out soon. So please do pay attention, and if you have suitable papers, and please do submit to our conference. So hope to see you all next year in Abu Dhabi. So and also we have planned 2 more distinguished IoT webinars in January and February next year. So in January, and our speaker will talk about artificial intelligence of things. And in February, our speaker will talk about satellite communications and IoT systems, about the future directions. So, and now it's our speaker today, Professor Carlos, and he's a full professor in the Department of Computer Engineering at the Technical University of Valencia in Spain. And his research interests including ad hoc vehicle networks, UAVs, smart cities, IoT, QoS, networking protocols, video streaming, etc. And he has published more than 500 papers in these areas. So Carlos has been served as various roles for IEEE conferences, journals, and communities. So he is a world's top 2% scientists, and also he's a senior member of the IEEE. So I would ask Carlos to start. And also for the audience, if you have any questions, and please find the Q&A at the bottom of your screen, and please post your question. Type your question in the Q&A session, and after Carlos' talk, and we will take the questions. Thank you. So I'm stop sharing, Carlos, and could you please share your slide?
Thank you, Wenqing, for your nice introduction. Welcome, everyone. So my thanks to IEEE IoT Technical Committee for your invitation. So just allow me to share the slides. So can you please confirm?
Yes.
You can see the slides.
Slide. Yes.
Okay, so I will start. So yeah, in today's talk, I'm going to present like the key challenges and the applications that we have today in this very interesting field of drones. So just a second to put on. So this is just quick information about myself and my research group. So I have put here this QR code in case you quickly want to take a look at my webpage using your smartphone. So starting with the seminar. So why are these drones so popular nowadays? So we know that they are widely used in in the war scene. Okay, unfortunately, so this is a reality. But thankfully, there are many other civilian applications where they are having very good uses and being helpful to mankind. And here we have typical cases for search and rescue of lost people. Okay, we also have, for example, the case of precision agriculture. And in some other fields, we are also starting to see how they are actually like starting to see initiatives like for human transportation. So just next year, maybe if you go to United Arab Emirates, so they do have the drones flying around in some parts of the country for selected paths. And then, well, everyone knows the popular light shows that we can have with drones. Okay, so this is less of a challenge, okay, but more from the entertainment side. But well, this at the end make UAVs become quite popular. And from the research perspective, I want to highlight then what key challenges remain. So before proceeding, because this also intends to be like a tutorial for people not so familiar with drones. So to understand correctly the terminology that we use in this area. So the term drone, that is the concept we are mostly using, is in fact quite generic, and it applies to any unmanned vehicle, can be even aquatic, subaquatic, or terrestrial. Okay, so when we talk about flying drones, then the correct term would be unmanned aerial vehicle. But there are different categories for unmanned aerial vehicles. So on the left side here, I have put as example the fixed wing aircrafts, okay, which can be the large airplane style or the swinglets that we can use for research. So these differ from the copters that we have on the right in that they cannot stay quiet on a fixed position. Okay, so if you want to do some sort of recording, some activity where they must stay fixed, then you cannot do it with fixed wing aircrafts. But they can fly longer for same amount of battery. Okay, so here we have some trade-offs. So on the right side, we have the two basic types of copters. Okay, so we have the helicopter when we have the two rotors. And when we go to 3 and beyond a number of rotors, then we are here on the multicopter case. Okay, so the rest of my presentation is in fact about multicopters, okay, which is this subfamily of UAVs. So when we are talking about challenges on autonomy of these multicopters, you here have the standard classification on these levels of automation that we can have on drones. So on the left side, we have the no automation case, which means that the pilot is handling all the drone mobility 100% manually. So this for in the racing field, okay, so this is the common paradigm, okay, so no automation. But this is like quite complicated. You must have high skills. So this is not comfortable for the pilot just doing regular missions and for research purposes. So in fact, we want to move towards higher degrees of automation. So throughout the years, I have seen a bit how this technology was evolving in the last decade. And we could see that at the beginning, initial efforts introduced very little automation. For example, the drone is able to maintain only flight altitude. Okay. And then we started introducing drones with more intelligence, and this was the eruption of DJI, a Phantom type of UAVs. And at this level, we already include the concept of mission. So the drone is able to autonomously follow a mission. And then they can either alert the operator about some issues, or in some case, for example, for level 3 automation, it can even include sense and avoid systems. So this means that, For example, it's doing a mission and then there is some tree or building in the path, and it can automatically respond to that situation by altering its route, changing altitude, etc. So moving towards higher levels of autonomy, we have the example of level 4 autonomy, and this is already present in any top quality drone that we can buy nowadays. And it includes, for example, the automatic following of the operator. Okay, so it locks, for example, into the person, and the person is walking, and it does the mission in an autonomous manner. So the highest level of automation, level 5, is a level that, to my knowledge, we have not yet reached that level. So what do we expect with full automation? That the mission itself is not decided by a human, but the drones and let's say an AI intelligence is able to decide what the drones should be doing. Okay, so it sees the situation and the conditions, decides that some mission should take place in order to, for example, go and find some intruder since there has been an alert. So it schedules the flight, the drones will do the mission, they will return, everything without human intervention. So this type of autonomy we can see, for example, in this series that's from Netflix. Okay, so here they have a type of Orwellian surveillance system, and the central intelligence assigns like a UAV that is following each person and autonomously it replaces like broken UAVs. So if you like this area, it can be a very good example of this situation. So let's go for the research challenges now. So what I was telling you before about the autonomy of drones, obviously this 5-level taxonomy is addressing single drone problems. So we know perfectly that nowadays we also have drone swarms. So this substantially complicates the problem and introduces new challenges. So next we are going to see some challenges, some that are single drone, some that are multi-drone challenges. So we start with something relatively simple, let's say. So package delivery and retrieval. So several years ago, Amazon promised they would start delivering this, and I guess in the US they are already delivering in rural areas, particularly packets to people. So in Europe, we don't have that yet, and maybe it will take a long time before we can actually see this in urban scenarios where the delivery is quite complicated. So we don't have like big gardens in our homes waiting for the packets to be delivered. But yet, delivering a packet is always much simpler than retrieving packets. Okay, so imagine you say you open up your Amazon purchase and say, oh, I don't like this, I want to send it back, and then you request a drone to pick it up. So the problem here is complicated a lot because of the degree of accuracy and the robotic challenge that involves in picking up. So I'm showing here a video about a solution that we developed already a few years ago. And our goal was just to land on an exact spot, okay? No packet to grab, no complicated challenge in that sense, but just landing on a precise spot using nowadays technology. It's still difficult, okay? So we could achieve with these markers on the ground and vision systems, we could achieve accuracy of a few centimeters. Okay, so in order to grab a packet, maybe we need like millimeter level accuracy, okay, in addition to the robotic arms and this type of elements that are involved. So this is still an area that requires more research, okay, so I will go back to robotics at the end. Now we go on to the next challenge, which is aerial sensing. So when drones became like popular for consumer side, usually it was for recording video. Okay, so in weddings, in groups of friends going skiing. So getting video was the main purpose. So besides this type of applications on the professional side, we can equip the drones with different types of advanced sensors. Okay, so like multispectral, hyperspectral cameras, or even lidars. And these sensors are much more expensive than the drone itself, in fact. Okay, so it can be like 10 times the price of the drone. And with this, we can apply sensing to like precision agriculture, like I was telling you at the beginning, with important benefits in terms of the accuracy and the feedback that it is providing us in these areas. Okay, so it has obviously applicability in many different areas. So precision agriculture is just one of them. So in the case of my research group, to show you a practical case, we are now working on a project whereby we intend to pollinize watermelon flowers. Okay, so this involves coordination with like a chemical agriculture company, okay, that provide the products for the pollination of the flowers. And we also have a UAV company. And then we are integrating this intelligence so that in real time, we can detect the flowers. So they are in fact very small, not what you see here on top. So they are very, very small flowers. And you are flying from a high altitude. So the idea is that using a type of a Jetson or in Nano or a similar platform, we can recognize the presence of these flowers. We can count the density per square meter of these flowers, then make a decision on whether we should spray the product or not, according to company criteria on expenditure. And then this will be in interaction with the flight controller that we have here. Okay, so the idea is that the drone can think by itself and just on the fly in real time, seeing what it has below. I have to spray, I don't have to spray. So this will improve the performance of precision agriculture compared to current solutions in many different ways. So we reduce the total times, we can reduce the amount of product we have to spray. Okay, we can do it a lot faster. So many advantages can be achieved using this type of solutions, and we will continue seeing this intelligence being brought on board to automate this type of procedures. Now, beyond basic sensing, here I introduce also some advanced sensing solutions. Okay, so this is an area that is called ISAC, so Integrated Sensing and Communication. It's a big part of the next generation cellular networks, so 6G. And what we can do here is that we use the communications channel also to provide feedback about sensing, for example, which users are in some areas to work as a radar. It can be quite helpful also for locating people that are lost, for example. Okay, so for example, we can provide cellular connectivity and do ranging in order to check where exactly they are located. So this is also a very hot area nowadays, and well, you can already find plenty of publications, but there is still a way to go, and there's still some standardization efforts in this very interesting area. Now, continuing in the wireless side, then we have also the problem by itself of extending coverage. Okay, so in general, when you have specific types of events like concerts or football matches, so the problem for cellular operators is that we have a peak of users, and they are located in this very specific area. And in addition, they are also generating a lot of content, right? because if you are in a concert, maybe you want to stream live what you are seeing. So these are bandwidth hungry users that are all located in the same place. So what this causes is that the network resources will be overwhelmed by these situations. And then the idea is that drones, they can serve as on-demand base stations that you can deploy to provide additional coverage and additional bandwidth support for this type of events. And once the event finishes, then you can remove the drones and go back to the standard operation. Okay, so this initiative, in the case of IEEE, it is being addressed by this P1954 working group, in case you are interested, and take a look at their webpage. Okay, so this is a hot area, and also a lot of work being done. Then from the perspective of giving the support for services that UAVs are now providing. So think, for example, about UAVs that are bringing some organ for a transplant, so making the runway between two different hospitals in a city. The idea is that we can provide very good links to these UAVs, okay, from the cellular infrastructure, with the problem that till now the users we were providing coverage to, they were located on the ground. Okay, so the lobes for the different antennas, they were all optimized to give this very good coverage in cities, but pointing downwards. And the situation now is that we have the UAVs flying in urban space, and they can be flying at 120 meters of altitude. So now, how to provide also good coverage for aerial users, for this new type of aerial users. So in this regard, significant contributions are being made in MIMO antennas that can dynamically redirect this energy for the different lobes, so that they can track the UAVs and maintain this constant connectivity with quality of service guarantees, and minimizing losses and delay, so that the operator, it can see in real time what the UAV is seeing during its flight, and can respond to any unexpected events. So another very interesting topic is the sense and avoid. Okay, so in case of my group, we are directly working on this topic, and the idea is that okay, so in the past we had civil aviation, now we have drones, now they must share same space, so we want to avoid collisions between civil aviation and the drones, but also between drones themselves. Okay, so I think the biggest challenge is possibly avoiding the collision between drones themselves, because they are sharing the same flight altitudes and similar parameters. So in the case of Europe, we have this U-Space initiative, which seeks to somehow define the strategy and the efforts, orient the efforts towards a U-Space that is offering all the required services to achieve a high level of drone automation, and also to provide a very good level of drone connectivity. Okay, so you have here the expectations that we have towards 2030. Okay, so but reality is often lagging a bit behind. So how does U-Space address the management of conflicts that can arise when two UAVs want to go towards a shared space in the air? So they are defining, on one hand, strategic conflict management. So what is being done is that before takeoff, you are checking the missions and reservations of airspace, and if you find that there is some potential conflict, then you deny that mission, or you delay it to a later moment. Okay, and then when the UAVs are already on the air, you have tactical conflict management. So in this case, it requires that you are constantly monitoring what is happening in the airspace. And finally, make sure that the distance between UAVs is sufficiently large at all times to avoid that they crash. So ideally, we would always be in this first case for strategic conflict management. But the problem is that how things are usually handled is that when, as a flight operator wants to do some drone mission, it defines an area and says, I will occupy this area during the entire morning because I'm doing here some operations. And that is not very practical, because then if you have a UAV and it wants to cross that area, it will be forbidden. So maybe it has to take a big alternative path. Maybe you don't have enough battery to do that. Okay. Or directly the target waypoint where you must land, for example, is inside the geofenced area. Okay. So in order to address this problem, then what they call dynamic geofencing plus management of aerial conflicts is what is being envisioned right for this year in EU Space Phase 3. So to avoid this collision, okay, obviously we have like many ways to do it, to detect that another UAV is around and to avoid colliding with it. So most of the works that you see in the literature are using sensors on the drone itself to detect other drones, okay, and then once detected, you avoid. In the case of my research activity, we'll replace all this with wireless communications. Why? Because I come from the ad hoc networking field, okay, so I moved to VANET, also communications, and it has a very good potential to solve this type of problems. So the sensing is just allowing drones to talk to each other, and then they cooperate on finding a solution that avoids collision. So I'm going to show you very quickly a case of a geometric protocol for solving collisions. So the idea is that we do a type of stop signal that is virtually enforced when flying. So if they are going to collide, they talk to each other, they detect each other, so they decide to stop, then one of them will have preference. Okay, so we make some checks about the safety distance. So if you have some proximity issue, one of the drones can even move back a little, and the drone with highest priority will then be allowed to move forward, and the other one will be signaled to continue. Okay, like when you are driving, a very similar strategy. So in this short video, you can see in our ArduSim simulator how the protocol we are developing is actually working. So the idea is that the UAVs, they are broadcasting the future positions, which are represented by these circles. So the next seconds of estimated positions, they are shared and broadcasted with all aircrafts around. And when they find that they are in danger, so they do this stopping, as you can see here. Then one of the UAVs is moving aside in this case to allow room for the other to pass, because they were on purpose on collision course. And then when the first UAV crosses that area, it signals the other one, say, okay, you can resume. And basically this type of solution, despite not being the most efficient, is like very safe for all cases that we have tested. Okay, so no collisions in any of the tests that we did. An alternative that is a bit more risky is to rely on attraction repulsing forces that are emulated via mathematical calculations. Okay, so we are estimating what is the resulting force between the attraction towards your destination and the repulsion that is exerted by nearby aircraft. Then you have a resulting force that will be your resulting vector, which determines the direction where you will be flying. Okay, so at the end, what we have is that the trajectories are deformed when the UAVs are flying nearby, but they never stopped compared to the previous solution. And with this approach, for example, in the face-to-face situation that you saw before, we can reduce the total mission time by 25%, okay, when doing this type of challenge. Okay, so obviously this is more risky because it is more unpredictable. So like with magnets, so you put them together, you don't know how the other is going to bounce and which direction it is going to take. But what you know is that the problem is solved much faster. Okay, so in this direction, we have different publications and we are still working on improvement to have like the best trade-off between safety and the performance that we can achieve. So up to this point, we are discussing solutions that require UAVs to talk to each other. Okay, so this slide is to emphasize on the UAV communications problem. Okay, so why do I say here emphasis on problem? Because all the standardization efforts, or most of it nowadays, are between the UAV and the ground control station. Okay, so the operator is on the ground. You want it to have very good link with UAV, and this is being solved in an excellent manner by the different task groups. Yet, when you talk about UAV to UAV communication protocols, here we have issues because there is no standard yet. Okay, so there are IEEE work groups that are focusing on this problem. So here I have the ASETI work group and the P1920.2. Okay, so maybe we can expect a standard to come out soon. But in terms of commercial products, there is still no technology that we can actually try on the field, similarly to what we have for vehicular networks with, for example, 802.11p and WAVE type of devices. So this is clearly missing, and it is fundamental to address these type of solutions I was showing you before, and also what comes next, which is swarm management. Okay, so I'm very big fan of UAV swarms. I don't have time today to go in detail into all the challenges that arise around UAV swarms. So I will just briefly highlight key points. So here we have collision avoidance and real-time synchronization while in flight. Okay, so that's an obvious requirement. The reconfiguration of the swarm formation while in flight. Okay, for example, they are adopting like a narrow pattern or a linear pattern, then you want to reconfigure into a matrix due to mission requirements. So in doing this on the air safely and fast, okay, I can tell you is a significant problem. And then the order takeoff and landing. Okay, so I have here a video for a protocol that we developed for the first of these problems, how to fly in a synchronous manner. Okay, so this was a relatively easy problem to solve. So you have a leader for the swarm formation, you have then followers at each waypoint. They are confirming that they have arrived to the waypoint. This is done in real time, so you cannot detect any delay. So this type of solution is not really hard. And the takeoff problem, in fact, so to be quite more challenging. So here I'm showing this video from China that has the World Guinness record for more than 5,000 UAVs that are flying simultaneously. So on the video, you can see that they took their time to prepare perfectly over a football field, every drone evenly separated. They are taking off and vertically and reaching their aerial position immediately. But if you are in any other type of scenario and you must very quickly deploy a UAV swarm and you just put the drones randomly on the ground and you have some expectations about what type of formation you need on the air, the problem becomes quite more difficult. Okay, So in different publications, like the one I have here on the bottom, we have addressed this problem by dividing it into 5 different steps, each one with its algorithm or algorithms tested. So the solution seeks that we rely on the UAVs to find the solution to the problem by themselves. Okay, so no central server deciding things here. So they talk to each other. They know they will be deployed randomly on the ground. They know that there are some expectations about the aerial formation. So between them, they will decide who should go in each aerial position, which is what you have depicted here. And then they also detect if taking off simultaneously will cause them to crash with each other, right? So we include mechanisms to detect possible conflicts in their trajectory, and then we divide the takeoff into, for example, different batches, so that different batches do not generate conflicts between each other. And there is even a maneuver management phase for those cases where the UAV swarm is so compact or so long that some UAVs are flying very near to the final positions of other UAVs. Okay, so yeah, if you want more details on this, I invite you to check these papers that I have here and on the end of my presentation. So switching to other types of challenges, you know that nowadays, so AI is a big deal, okay? And we also want to have drones everywhere. So up till now, these flying drones have mostly been deployed outdoors. So efforts are also being directed towards indoor mobility, and this has been going on for several years. So when you are flying indoor, then AI must almost mandatory come into play. Why? Because you want to be able to understand what is around you, okay? And there are people, there are animals, doors are being opened and closed. So just the detection of static obstacles, like I have here a box, or I have here some column or whatever, are not enough for actually agile mobility while indoors. So all the traditional robotic challenges about localization, navigation, and mapping, similar to what we have for our Roomba cleaners for home, right? So they are already doing this. So from the aerial flying robot perspective, these challenges still remain, but we must bring on more intelligence, cameras, and AI so that we better understand the dynamic scenarios and how to interact with human beings and with animals adequately. So in the AI field, okay, here I have also put another example of what drones can be useful for. So one of the problems that we had, especially some years ago, is that you want to do training for vision-based deep learning models, and you don't have enough data sets, okay? Because the UAV type of view is very particular, okay? So you have this very zenithal view of the situations. So only a UAV can create data sets that are useful for other UAVs. So in our research group, often we had to make flights on target areas that we want to study to first create the data sets, then do the training, and then create the deep learning models, and then be able to reach some conclusion. Okay, so these type of objects, I can count them, I can classify them. So this is also a very interesting work area. As an example of applications that we have been working on, maybe you heard about the floods in Valencia 1 year ago. So there were a very serious problem with lots of people dying and unexpected water coming to when there was no rain, and suddenly like everything was flooded. So how can UAVs be useful after a disaster of this kind? So we have developed some models, again, using this type of NVIDIA Jetson devices that you can equip on the UAV itself, so that when flying around any flooded area, you can train the UAV to distinguish between what is flooded, like what is a building, what is a tree, what is a vehicle, what is a road, and if it is flooded or not. Okay, so that we can really help authorities to understand where the main problems are located, okay, and then send firemen or other type of equipments. So in this case, we could also go for an alternate solution, like I am stating here below. So deploying a type of edge server, for example, on a vehicle, and the edge server is doing the processing. And in that case, you will need to have a very high bandwidth link between the UAV and the edge server in order to also do this computation in real time. Because at the end, the challenge is doing this in real time and not taking many hours to provide this feedback to the authorities. So other type of challenges for UAVs, that these are really specific to UAVs, have to do with flight time extension. Okay, so in case of Valencia, like we were leaders through this company, you say here, Quaternium, and for many years ago, they already developed one of maybe the first worldwide UAV that was hybrid combustion and LiPo. Okay, so this could fly between 2 and 4 hours, which is quite a lot compared to the traditional LiPo-only UAVs that can fly between 20 and 40 minutes. And then there are initiatives, for example, from the military side, where they want to have real-time tracking of the UAVs and recharging of the drones by sending them energy pulses directly to their location. So this is still under development, okay? So no products out yet, but it has some potential. Okay, similarly to the induction loop recharge problem. Okay, so in this case, the UAV is confined to a very short area, so you can maintain it flying, and you are trying to deliver energy to the UAV. So this is not successful till now, but what is more successful is the idea of having induction loops recharge the UAV once they land, similarly to rechargers for vehicles. Okay, so the UAV is bandwidth hungry device. So once it lands, you don't need an operator to go there and change the battery, but you have this wireless recharging. Okay, so that is also a problem that is being tackled these days, and very interesting as well. Then the problem of handling rogue UAVs. Okay, so this you have seen a lot lately because of the different wars going on. Okay, so UAVs infiltrating from airports and all other places. They really disrupt flights, and everything has to be stalled, right? So it's very important to be able to detect the presence of the UAVs and then respond or say act upon these UAVs. So here you have an example of a portable UAV detection system. So what are the methods that are applied for each of these tasks? So usually for detecting, we can use traditional radar or just detect radio frequency sensing. Okay, so to avoid this, for example, in Ukraine, they use fiber optic cable, so no RF, okay, so that you cannot sense it that way. Or you can just use cameras to see the drone, or by noise, because they are noisy devices, or by fusing different types of sensors. Okay, so once you detect, then you want to stop or mitigate this UAV. So the most elegant way to do it is take over. Okay, so you take over the wireless link. So you control the drone and you force it to land. And then you have physical capture systems like nets, okay, or even another drone can launch a net over the drone, or you have directed energy systems like the energy pulse generator you can see below. You can also include kinetic interceptors, like, for example, an eagle or a projectile. And finally, you also have the option of geofencing technologies that require integration with the UAV manufacturer and agreeing that some area will be forbidden for flight. Okay. So we go now to the last challenge. Okay, so I left the most difficult part for last, which is robotic manipulation. Okay, so in this direction, the United Arab Emirates, they have for several years created an international challenge whereby different teams have, for example, to coordinate both ground robots and UAVs to create, for example, a type of wall. Okay, so robots coordinating and trying to mount a wall. But just having one UAV doing it is already hard enough. So robotic manipulation with an aerial device is, from a robotics perspective, like a small nightmare in terms of calculations to be done. And well, I will just play back this video for a few seconds because it's a bit noisy. So you can see it's trying to put a staircase. Okay. Okay, so what are the problems with robotic manipulation? That you have higher flight instability, okay, because now the drone does not have the center of gravity so well balanced because you have a mobile element and the weight is tilting towards one side. And then you must combine this with the all existing limitations of UAVs, that you have limited payload and limited energy that you can use. And then also the precision problem I was telling you at the beginning, okay? How to accurately grab some elements. So obviously you will need AI and integration with the robotic part in order to see and grab. And what is maybe the top problem here is the couplet dynamics problem, okay? So you have the manipulator or this robotic arm that is affecting the UAV flight stability, and UAV flight is affecting the position of the robotic arm. Okay, so this couplet dynamics problem makes it particularly hard to solve. So if there are any people here that are doing robotic studies, so this is a very, very interesting research topic to work on. So to conclude my talk, so the key ideas, okay, so I don't think it took much convincing that UAVs are a hot research topic. And today I have to talk to you about sensing, communications, use space challenges, how to avoid collisions between UAVs, how to handle swarms, indoor navigation, AI, etc. Okay, so many, many research topics. And we have like gaps, research gaps in all of them. Okay, so for my research, the one that is more striking is that no standard for communications between UAVs is still out there. Okay, so that causes some restrictions, especially when you want to bring this to commercial products. And also that what we were talking at the beginning for this level 5 autonomy, so bringing AI to UAVs, making UAVs smarter and more autonomous so that they can make decisions for themselves. So this is the next frontier to reach. So with this, I conclude my presentation and I will now be open for questions. Thank you very much.
Thank you so much, Carlos, for the very interesting talk. You have explained everything very well. So, and the introduction of the challenges of UAVs and their applications as a standalone device or as a part of the swarms are very comprehensive in my view. And also, I think your research results probably give us some ideas how to develop our research. So thank you so much for the very informative talk. So let's start the Q&A and take the questions. Carlos is, and I saw there's some hands raised up. So please type your question in the Q&A session. So if you don't mind. So let's go to the first question, and Carlos, and is in the Q&A session at the bottom of the screen. So the first question is from Dennis. So basically the question is that I think the question is related to the one that you showed some demonstration that two UAVs, if they are flying, they meet each other, and one UAV will clear the way and the other UAV can pass. So the question from Dennis is, he thinks this is a 3D program, and maybe we can adjust the altitude and instead of, so
Yes, in fact, I have been asked that like many times.
so
Yes.
why
So,
didn't you?
in fact, regarding Dennis' question, so for commercial flights, I think it was in 1960s or 70s or something like that, there was a big accident of two commercial flights colliding. And from that moment on, they had to include transponders to detect other incoming flights and change altitude. Okay, so that was and still is the solution that is being adopted in commercial flights. So what is the problem with UAVs? That unlike commercial flights where the airplanes have a big margin, okay, of altitudes to move around because they can fly at 8 kilometers altitude, 10 kilometers altitude, and beyond. In the case of UAVs, we have maximum altitude of 120 meters. Okay, then the minimum altitude is often defined by building heights and other requirements. So we are already on a much more thinner layer. Okay, so you combine that with, for example, GPS accuracy regarding altitude. So GPS accuracy regarding altitude is much worse than for XY positioning, let's say. So maybe you are actually 10 meters higher or lower than what you believe. And if all those combined restrictions were not enough, then when you see initiatives like USpace, they want to regulate strictly the flights of UAVs in these urban areas, and they want to define like layers for flying. So maybe in this layer, UAVs can only move in this direction or this type of missions, and then there is another layer, there is another layer. So this is restricting more and more your margin of maneuverability here. So the indications that we receive from the work groups on this topic is that the solutions should in general be solved on the same plane and avoid changing altitude. Okay, so that's why the protocols that we are developing, most of them are limiting to a 2D problem. Okay, then in some cases we have also tried the 3D version with some minor improvements, but let's say the legal restrictions make us work mostly on the 2D problem.
Okay, I think that's a very good answer. So let's move to the next question, which is about the security of UAVs. And so Andres is asking, and so what are the most significant security risks in the centralized management of UAV?
Okay, so I'm not the very big security expert. Okay, so I have done some work in security. So in the case of UAVs, the risks are in fact everywhere. Okay, so centralized management of UAVs should in theory be more secure than distributed, or at least an easier problem to solve. So if you are going for centralized management, obviously you have the basic problem that if this central manager is compromised, then you can take over the entire swarm, a swarm of UAVs or UAVs doing some missions. Unlike the case where you have like distributed security, then if the UAVs have more autonomy and are not so dependent on a centralized manager, maybe you can take hold of one UAV or two, but not all the swarm. So despite distributed approaches are more challenging, I think you can make them like more robust to this type of attacks that could completely take over all your UAV operations. Okay, but I'm sure there are more authors that are experts on this type of security issues and can provide better and more insightful answers on that particular topic.
Yes, and for example, we recently published a paper which is about we find that authentication is actually a security issue in UAV networks. And what we did is we developed a cross layer. We used a cross layer fingerprint to enhance the authentication and to try to enhance the security in the UAV network. So and we also have a lot of data sets there. So in case you are interested, so you can contact me. So
Yeah, for example.
yeah, for example. Yeah. So and let's move down to the next question, which is about energy. So and you're talking about the UAV's flying time, and so we have our audience, Marion, and is asking that does it because of we can do the energy harvesting. So for example, use solar cells. So does it represent currently a positive cost or benefit ratio?
Okay, so Marlon, so the answer to this question is both yes and no, depending on the type of UAV that we are using. So going back to my initial slides, okay, so we have, I would just quickly go flying back to the beginning. Okay, so we had this type of UAVs, which are swinglets. So these are very light devices, okay? And whenever you have a flying device that has wings, the energy that you need to keep it flying is much, much lower than what you need for a multicopter, okay? So in the case of swinglets, if you have very light solar panels installed, then you can extend the flight time in noticeable manner. If you are talking about multicopters, then the amount of energy that they are draining, okay, it can easily reach 60, 80, 100 amps of current. Okay, so no solar panel is able to provide that bulk amount of energy. And that's why they also need this type of batteries, which are LiPo, that are big and heavy, but only this technology can provide this very high current to the UAV. So in the case of you need UAVs to fly for a very long time, then either you go for these hybrid solutions where you have like combustion or hydrogen engine in addition to the energy systems, or you directly have a cable connected to the UAV and you are limited to missions on very few meters around your locations. Okay, so as of today, we don't have any other solution to extend the flight time that actually works.
Yeah. So let's move down to the next question from the anonymous attendees. And its question is about satellite imagery. So can this be used for dataset for training instead of conducting flights? Use the satellite image as
Yes.
data.
Well, the question here is also it depends. Okay, so in general, my answer would be no. Thinking about the type of problem that we are typically addressing and the degree of image resolution that we require. So when we go for satellite imagery, I guess we are talking about like the open satellite images, that you don't own your own satellites that can have special cameras to address your solution. So we are going for open satellite image databases, and then you have limited resolutions there. Okay, so also depending on what you are training for. Okay, for example, the case I was showing before with the plants. Okay, so even flying the drone at 10 meters, it's very hard to see these plants, right? These flowers. So certainly not from any satellite can we do this type of training. There can be other cases where what you are learning is from very high altitudes to detect some features in the terrain. For example, if you want to fly around without GPS and just relying on the image sensor to locate yourself, then you can have a previous training with the satellite images and correlate with what you are currently viewing, and then you can geolocalize yourself. Okay, so in fact, we are also working on this problem right now. But that is a very particular case. And that particular case is also assuming that the UAV is flying at a moderately high altitude to have like this broader view of the artifacts that you have on the terrain. So yeah, depending on what is your goal, it can be possible, but I think that for most applications, you will not have enough quality data for this training. Okay, that is my impression.
Thank you. So let's move down to the next question. And the question is from Vijay, and I think it's about communication protocol. So basically, I think the question is asked about drone communication protocols. So how are drones communicate to each other? Means
Okay,
any
so
protocol. So
yeah. So I really like this question because it relates well to what I was complaining about, lacking of standard. So for example, in our case, so we are implementing solutions, and the drones, they are talking with each other. Okay, so if you see my webpage, some videos, it's working in real life, and we achieve this. How? Is it in a satisfactory manner from my perspective? No, because we are creating an ad hoc network using 802.11. We can also do it using Bluetooth, for example, but that is not generalizable to general communications, let's say, for example, in an urban scenario between UAVs. So what we need is something that resembles more the communications in VANETs, where in 811p you have this outside of basic service set paradigm communication. So you don't want the drones to be somehow previously linked to each other from a communications perspective. You want to allow new nodes to just join the network at any moment. So we should have a technology that enables this type of interaction between drones. So that from a physical MAC layer problem. Then on top of that, we are developing obviously our own protocols. Okay, and the slide I have here is in fact quite useful. Why? Because what we have right now is that we introduce an embedded system, usually a Raspberry Pi, and the embedded system is connected to the flight telemetry so that we can talk to the flight controller and have this bidirectional feedback. And then our protocols, they rely on the UAVs talking to each other, and then basing on their conversation, we can decide to change trajectory. So that's when we give different orders to the flight controller via the telemetry port. But the intelligence, it is running on another embedded system like Raspberry Pi or Jetson or whatever you want to run. And we are building our own software using standard TCP/IP protocol stack, generic application level solution with Java, with Python, or whatever language, and the protocols that we are working on. So they are designed so that this interaction, it can fit into small messages so that you can broadcast these events to your neighboring UAVs. Okay, so we use UDP over IP broadcast over MAC layer broadcast so that you have this reachability to nodes around you. So if in the future we have a specialized MAC physical layer solution that is designed for this UAV problem, then some adaptations will be required, but the application layer will remain the same. So the same intelligence can be adapted to different wireless technologies.
Thank you. I think that's a good answer. So move down to the next question is from Guido. And basically the question is about experiments of the research. So apparently it's very expensive to run the real UAV experiments, and also it's not allowed. So in most city doesn't allow you to fly UAVs. So, and you probably use some simulations.
Yeah.
And what is your simulator? And how do you actually enable that your simulator can actually reflect the real UAV physics and
Yeah, exactly.
auto
So
pilot systems, etc.
this is the first problem we had to face. Okay, so I started working on UAVs back in 2014, and we started building our drones, doing some flights, crashing the drones, saying, "Oh, this is very expensive." Also, we have many restrictions. You cannot fly in the campus, in the city. You have to drive to an airfield that is far away. So this is the reason why we developed ArduSim, which is the simulator you can see here, and that it is on GitHub, so you can use it for free. So what is different about ArduSim? We are using open source flight controllers. So these are the Pixhawk flight controllers. So there are already some drone emulation solutions for the physics part, where you can emulate, like using software in the loop, a drone in your computer. So in our simulator, we leverage this initial model in order to allow multiple UAVs to be running on the same computer, and then we provide all the communications layer between them. So this is running in real time, like a real UAV. So this is not actually simulated. This is emulated, because running in real time. So whatever protocol we are able to develop here in ArduSim, it talks with the UAV using a Mavlink interface, which is like a standard protocol for interacting with the flight controller. So this means that our code, once it is working well in ArduSim, we just port it to a real drones, and it also runs there correctly. Okay, so you have like direct porting. Why? Because the emulation inside your PC is done very well. Okay, and this interaction is exactly like the interaction in a real drone. Okay, so if you can have a real-time response and everything goes well inside your server or PC or whatever you are using, then you port to a Pixhawk based UAV. Okay, cannot be a DJI or a closed controller. You must use an open source controller, and then it should be okay in order to do this type of quick prototyping and testing.
Thank you for the very detailed answer. Let's quickly move to the next one. Is about how to detect or mitigate rogue UAVs. So you mentioned this type of UAV and how to detect and mitigate. I think they should have a lot of different research in the literature and to talk about this.
Yes. Okay. So I am not directly working on this area. Okay. So I don't have like papers on the detection methods, but I have like studied a bit this area. And nowadays it's becoming, as I told you, very hard to detect UAVs, because they are trying to minimize the ways to detect them. Okay. So you say, okay, radar, you try to fly very low, okay, and you use AI to see trees and whatever obstacles you have around and navigate. Then you have radio frequency sensing. And like what happens in Ukraine, they say, okay, no more radio frequency. We use an optical cable connected to the drone, no need for RF. Okay, so it starts to be hard. Then, for example, acoustic sensing. The drones, they are noisy flying around, but if they are at 200 meters altitude, you cannot listen to them. Okay, so you can only hear them when they are already too close for this type of detection. So there is like no optimal answer on what is the best detection method, because it will depend on what type of attacker that you have and what type of challenge does it introduce. If it was easy, then we will not be having all these problems in airports in Europe almost every day or every week, right? So I would go for the multi-sensor approach because it seems like the most logical solution when you really don't know how to do this well. So you want just to combine all possible sources of information to alert you and try to respond quickly. But keep in mind that if drones, they are able to fly very low, you cannot see them with radar or optical cameras or anything like that. So it can become almost impossible unless they are already inside your protected area. Okay. So in terms of mitigation, then some of the issues that are shown here, they are not useful, like geofencing and identification technologies. This is when you are well behaved and by accident you got into this protected area, because otherwise, for example, in military field, this is completely silly to think about geofencing to protect, right? So usually in war scenarios, kinetic interceptors are the most realistic, because you want to pursue the drone and try to destroy them. Okay, so no RF disruption, no physical capture systems for in war scenarios. So kinetic interceptors right now, I think they are the number one choice.
Hi, Wonton. I see that we were over time. I didn't know if you wanted to get another question in or move to closing statements.
Yeah, so based on Carlos, do you still have time to answer? We still have
Yes.
12 or 13 questions. You want to answer the questions? Oh, yeah.
Maybe we can take like 2 or 3 more.
Okay.
And then
Okay.
move
So
the rest
yeah.
offline. Yeah.
Okay. Craig, do you also have time? And are you in the
We have about another 15 minutes or so that the webinar can
Okay.
stay open. So I think whatever we can do within that time would be fine.
Okay. So the next question is from Linda, which basically asking if we develop machine learning models on UAV and what will be the cost. So basically, maybe what issue we should consider. So
Yeah. Okay. So this is a question quite related in this case to things that I am working on right now. Okay. So here we have some examples. So answering to Linda. So the biggest problem that we had in order for to do some training, for example, in the case of smart agriculture, for example, for monitoring bird species in natural parks and other projects we are working on. So first problem is to have a good data set. You cannot train without a good data set, and keep in mind the data set must be generated by a UAV. And flying UAVs, okay, it's complicated, many restrictions. So maybe you cannot have any data set at all. So you have to build your own data set. Okay, so that is problem number one. Then training the models. This is very standard, but you don't want the models to run on any device. You want the models to run on some device that the UAV can carry. Okay, so these devices, they have GPUs, but they have their limitations. Okay, they have memory limitations, so GPU limitations. So the problem is to make a model that is much smaller than those that you can run on the cloud and still have enough performance to serve your purposes. And the performance when you are in UAV is not only in terms of standard AI metrics like accuracy or precision, F1 score, etc., but you also want to see what is, for example, the frame rate that you can handle making this real-time analysis. Okay, so if you want to process, for example, 60 frames per second and detecting objects in real time, it can become a problem, a bottleneck. So maybe you have to adjust the flight speed of the UAV to the inference speed that you can have for your model running on the UAV so that it accomplishes its mission correctly. For example, if you are detecting lost persons and you are flying too fast and you cannot process all the frames in time, maybe you missed the person back there because you are not you are skipping too many frames, and the frame where the person was you did not get to detect it. So this is basically the summary of issues that we are right now facing when porting AI models to the drones. So in addition to the problem that the drone must be able to carry these additional devices, so that represents extra weight, and it's consuming a significant amount of power. So I discussed before that UAV, because of the LiPo batteries, it can fly for 20, 40 minutes. If you are deriving part of that power to one of these boards, and it has, in addition, to carry more weight, so instead of 40 minutes, maybe you have 15 minutes only. Okay, and then 15 minutes maybe not enough to accomplish the mission that you have in mind firsthand. So all of these trade-offs must be well studied and accounted for.
Yes. And speaking about datasets, and I'd like to mention, Carlos, if you need datasets, I have some UAV datasets here that we collected from
Yes,
a
that would be
network
excellent.
that
Please
running
share.
three different types of UAVs from three different manufacturers. So, and if you need it, and maybe we can see whether our datasets will fit the purpose.
Yes,
Yeah. Okay.
depends on the type of project. In some projects we have, they are so specific that we know for sure we must get the data sets. If it is a problem like the one shown in this slide, like differentiating this is vehicle tree, street, flooded, not flooded, that is more general purpose, and then you can take advantage of public data sets, of course.
Yeah, okay. Yeah. Okay, so let's move down to the Abdul, and he's asking a question about so UAV is type of IoT. So what's the difference between UAV security and general IoT security? So does it have contradicting types of manners?
Okay, I'm not sure what is contradicting type of manners,
UAV
but
is
I
very
will
energy
try.
constrained, right? So that's probably one type of thing that it designed the security uh, solutions need to consider about this. So
Yeah, so right now, UAV security. So when you're thinking about it as a flying, for example, IoT device, and you are thinking about an attacker that wants somehow to intercept communications or take over communications. The problem that we have compared to standard IoT devices is that we have many, possibly many open channels. Okay, for example, in the drones that we use, you have the remote control channel, and then you have the telemetry channel. And then we are adding our own wireless channels. And in terms of wireless channels, maybe you have cellular communications via 5G. And then you have some ad hoc communications for UAVs to talk to each other. So by having, let's say, more open possibilities for attacks, okay, so the attack front is wider. So immediately that makes it more prone to suffer from cyber attacks. Then some of these specific types of communication channel, like the telemetry. So the telemetry is very poorly protected nowadays, especially, for example, using this Pixhawk flight controller I was showing you. they all have the same type of telemetry devices, it's very easy to break in. Okay, extremely easy to break in. And once you break in, not only can you read exactly where the UAV is and what it's doing, but you can send commands to change orders and change mission. Okay, so not much protection there. Then if we go to the envision the smart city solution where UAVs are talking to each other and they are cooperating, the problem that we face in that scenario is the same problem we have been facing for 2 decades or more in ad hoc networks, vehicular networks, etc., which is, can you trust your neighbors and what they are telling you? Okay, so maybe I have a UAV telling me, oh, I am occupying this airspace, or please change your trajectory not to collide with me, and it is false information. Okay, maybe it just wants my UAV to move to an area where it can be easily trapped, for example. So I think this is quite more sensitive compared to IoT deployment scenarios. And keep in mind that in the security field, we also keep the cost-benefit relationship of breaking in. So if you are breaking in, for example, in an IoT temperature sensor, that is very cheap and no one cares. Okay, so for the attacker, this is not so attractive. But if you are talking about a UAV that is carrying, for example, a 20,000 euro multispectral camera, or if you are carrying a heart for a transplant, for the attacker, this is very attractive. So we will possibly dedicate a lot more resources into trying to break into the UAV security and taking hold of it. So I think here we are talking about another level of problems to be addressed. So any of you that are cybersecurity lovers, please come and work in this field because we really need better protection.
Yes. And I think it's quite, the time is quite all around, but we still have like 10 questions. So do you want to continue answer the question? Maybe Craig needed to go to.
Craig, do we have time for one more? Should we stop?
I would suggest that you do one more quick one and then move to closing statement, and we can follow up with all of the questions because they automatically get saved, and we can follow up offline with them. That's what I would recommend.
Okay, I agree.
Yes.
That's fine with me.
Okay, so let's take one more. The next one is from Mohammed. So Mohammed is asking you to highlight the current challenges faced by UAVs in smart transportation systems.
Okay, so smart transportation systems is a very broad concept. So I will talk about this under two perspectives. So first perspective is smart transportation considering UAVs alone. Okay, so in this regard, the current challenges, for example, that we are facing in use space is how to create, for example, aerial highways for UAVs to travel around the city, and that promote that you can fly a lot of UAVs. Okay, so there is actually some metric of how many UAVs per minute can you inject into the system without causing collision problems. So how to handle the airspace and organize the aerial traffic so that the aircraft, they are well organized, maintaining safety distance, that you can have a continuous monitoring of their position, if they are following their mission without delays, if there are delays, if they are going away from the reserved path that was allowed for their flight. So there are a lot of issues here that we are also working on. So I hope to have a paper on that particular problem pretty soon, because it's really beautiful area, no? Like it looks like this old movie from Bruce Willis where he was a taxi driver, and then there was some alien aircraft that was coming in. So you could see all the vehicles flying above the city. So we want something similar for the UAVs. Okay, so smart transportation from that perspective, including even humans being transported by UAVs without crashing. So that's one challenge. And then another challenge is how can UAVs contribute to improve ground transportation, okay, with our cars. So in this other area, many different works are seeing how UAVs can, for example, adopt AI or just using their cameras to bring feedback about which part of the city are more congested so that authorities can, for example, act upon semaphore timings and other bringing the police there, or if there was some accident and then some radioactive fuel is causing trouble in some part, so that you map exactly which part was affected. So keep in mind that after all, UAVs are on-demand devices, on-demand flying robots that whenever you have a problem, you can deploy them in order to get a quick feedback. So this slide is all about that. You deploy them on demand. You know they can fly for little time, but you make very good use of that time for any challenge that you are facing. So if it is smart transportation, good. You have problems, you send the UAVs in, they monitor the area, they give a quick summary of what problems have been detected and what are the best approaches to quickly solve that problem. So for an operator to have that information already summarized and in an explainable manner in real time and fast. So that is there is no price for this type of information.
Thank you so much for this insightful Q&A session, and thank you so much. So yes, and we need to continue to develop the UAV technologies, so we will make the sci-fi world become the real world. So and I think that will be the last question that we'll discuss in live. So if you have further questions, you are obviously welcome to send your questions to Carlos, and I
Yes.
believe he will be very happy to answer your questions. So thank you
Yes,
so
yes,
much,
of course.
Carlos, for your time and efforts.
Thank you,
And
Wanqing,
also thank you.
for sharing. It was a pleasure to share this afternoon with you today. Also, thanks to Gray, and thanks to all the people that attended. And yes, looking forward to meet again in the future.
Yeah, thank you so much for all the audience as well. Thank you. So looking forward to see you to the next year.
Yes,
Okay.
thank you,
Bye.
everybody. Thank you, Carlos. Thank you, Wanching, for hosting, and look forward to everyone joining our next IoT webinar. Have a great day. Bye.
Bye-bye.
Bye-bye.